Hello, sir.
Hello, and good morning to the fifth session, and we'll be continuing with chapter 2 of Statistics for Economics. So, yesterday, as per the activity, we had to distinguish the following variables as continuous and discrete. So, a rainfall can be a continuous variable.
Yes.
Yes. And can age be continuous or discrete? It can be only discrete because age cannot be 56.2, for example, right?
Yeah. Yeah.
And number of cars and road will also be uh, discrete because it cannot take any fractional
Yes.
value. Only rainfall
Yeah.
can take centimeters, 1.6 meters or 156 centimeters, something like that. The
Yeah.
rainfall is discrete, and crop yield also can be rainfall is continuous, whereas crop yield also can be continuous as well.
Yeah.
And so this example 4 shows how the marks of 100 students are grouped into classes. You'll be wondering as to how we got it from the raw data of table 3.1. But before we address this question, you must know what a frequency distribution is. So we'll study the concept of what is a frequency distribution. So textbook activities are quite fun because there are a lot of activities which we need to answer in one word or two words. So we'll have to solve most of the activities given in the textbook so that we'll be thorough with the concepts. A frequency distribution is a comprehensive way to classify raw data of a quantitative variable. It shows how different values of a variable, here the marks in mathematics scored by a student, are distributed in different classes along with their corresponding class frequencies. In this case, we have 10 classes of marks 0 to 10, 10 to 20, and till 90 to 100. The term class frequency means the number of values in a particular class. For example, in the class 30 to 40, we find 7 values of marks from raw data in table 3.1. They are 30, 37, 34, 30, 35, 39, 32. The frequency of the class 30 to 40 is thus 7. But you might be wondering why 40, which is occurring twice in the raw data, is not included in the class 30 to 40. Had it been included in the class of frequency of 30 to 40, it would have been 9 instead of 7. The
Yeah.
puzzle will be clear to you if you're patient enough to read the chapter carefully. So we'll carry on and you'll find the answer. Each class in a frequency distribution table is bounded by class limits. Class limits are the two ends of class. So out of a class limit of 60 to 70, which is the lower class limit here? The lowest value is the
60.
lower class limit. Yes, that's right.
Yeah.
And 70 is the,
Upper class limit.
yes. And its low class limit is 60 and its upper class is 70 as we discussed. Class interval or class width is the difference between the upper class limit and the lower class limit. For the class of 60 to 70, the class interval is 10, upper class limit minus lower class limit. So the difference between the lower or the upper class limit will be the class interval.
Okay.
And the class midpoint or class marks the middle value of a class. It lies halfway between the lower class limit and the class limit of a class and can be ascertained in the following manner. Class midpoint or class mark is equal to upper class limit by lower class limit divided by 2. So here in this case of 60 to 70 class intervals, or there's a difference of 10. So we need to add 60, which is the lower class limit, and 70, which is the upper class limit. We get the value of 130 and we need to divide it by 2. So the interval or the class midpoint will be 65. So the
Okay.
class mark or mid value of each class is used to represent the class. Once raw data are grouped into classes, once they are grouped into classes, they can be Individual observations are not used in further calculations. Instead, the class mark is used. So there's a table 3.3 here.
Yeah.
So what can we infer from the table here? The lower class limit, the upper class limit, and the class mark is given. So out of the class width of 0 to 10, there's a
Yeah.
frequency of 1, and the lower class limit is 0 and upper class limit is 10. The class midpoint or the class mark is 5. So we are clear with this concept.
Yeah.
So just to find the class mark or the class midpoint, we need to add the lower class limit and the upper class limit, and the answer which we get, and we need to divide it by 2. The frequency will be mostly given in a subject of statistics. Frequency curve is a graphic representation of a frequency distribution. Figure 3.1 shows a diagrammatic representation of the frequency distribution of the data in our example above. To obtain the frequency curve, we plot the class marks on the x-axis and frequency on the y-axis. Okay. And diagrammatic representation of a frequency distribution of data is given as follows on page number 29 of the textbook. So the highest frequency is for 0 to, or 20 to 25, or from 40 to 60, it is 23 or 22, 22.5, right?
Yeah.
Probably it is for the class width of 40 to 60, there's the highest frequency of more than 22. It's close to 20, 23 probably. Yeah.
Yeah.
There is also between 50 to 60, that's going above 22.5. So it is 23 between 40 to 60 in this point. So can we move ahead to the next concept? It is how to prepare a frequency distribution. So to prepare a frequency distribution, while preparing a frequency distribution, the following 5 questions need to be addressed. Should we have equal or unequal sized class intervals? How many classes should we have? What should be the size of each class? Or how should we determine the class limits? And fifth question is, how should we get the frequency for each class? So to have equal or unequal sized class intervals, there are 2 situations in which unequal sized intervals are used. First, when we have data on income and other similar variables where the range is very high. For example, income per day may range from nearly 0 to many hundred crores of rupees. In such a situation, equal class intervals are not suitable because, one, if the class intervals are of moderate size and equal, there would be a large number of classes. If class intervals are large, we would tend to suppress information on either very small levels or very high levels of income. Second, if a large number of values are concentrated in a small part of the range, equal class intervals would lead to lack of information on many values. In all other classes, equal-sized class intervals are used in frequency distributions. So we know what the class interval is, we know what is frequency, we also know what is a class midpoint or class marks. And next is how many classes should we have? The number of classes is usually between 6 and 15. In case we are using equal sized class intervals, the number of classes can be calculated by dividing the range or the difference between the largest and smallest values of variable by the size of the class intervals. So there's an activity given here. Find the range of the following. The population of India in example 1. Do we have a range for it?
Example 1.
Yeah. We'll just
Which,
go back to example 1.
yeah.
So there's a population of, can we give a class range for the population?
Yeah.
So can you start from which value?
From 35, no,
Yeah, from
from
35 to
121.
from 35 to 121. That can be
Yeah.
the range. And what is an exact definition of a class range?
From where it starts to where it ends.
It's the difference between the largest and the smallest values of variable.
Okay.
It is
Yeah.
known as the range. And for yield of wheat in example 2, we can also have a range. We'll just go to example 2 to find out what is the yield of wheat. So yield of wheat for different countries in 2013. What class range can we give? We can give it from the lowest or the uppest,
Yeah.
2,787
Yeah.
to
To
7,998.
7,998.
Yeah, so from
Yes.
Pakistan's yield of wheat, which is the lowest at 2,787 kg per hectare, to Germany's yield of wheat, which is 7,998 kg per hectare. So
Yeah.
that's the range. So we have solved another activity here. So we should be solving more activities because it will be easier to follow the lessons. What should be the size of each class? The answer to this question depends on the answer to the previous question. Given the range of the variable, we can determine the number of classes once we decide the class interval. Thus, we find that these two decisions are interlinked. We cannot decide on one without deciding on the other. Is in example 4, we have the number of classes as 10. Given the value of range is 100, class intervals are automatically 10. Note that in the present context, we have chosen class intervals that are equal in magnitude. However, we could have chosen class intervals that are not of equal magnitude. In that case, the classes would have been of unequal width. So when there's a range of 100, the class intervals are automatically 10. So we have 0 to 10, or from 10 to 20, 20 to 30, and so on until 90 to 100. We are also choosing the class intervals that are equal in magnitude. However, we could have chosen class intervals that are not of equal magnitude. In that case, the classes would have been of unequal width. So if they're not equal, for example, there's a range of 100, and we choose the class width or the class interval between 0 to 15. So it may not be an equal width, right? Or from 15 to 30,
Yeah.
or
Yeah.
from 15 to 28. They'll not be of equal width. So the classes will definitely not be of equal width in those type of class intervals. So how should we
Yeah.
determine the class limits? Class limits should be definite and clearly stated. Generally, open-ended classes such as 70 and over or less than 10 are not desirable. The lower and upper class limits should be determined in such a manner that frequencies of each class tend to concentrate in the middle of the class intervals. Class intervals are of two types: inclusive class intervals. In this case, values equal to the lower and upper limits of class are included in the frequency of that same class. Exclusive class intervals. In this case, an item equal to either the upper or the lower class limit is excluded from the frequency of that class. In the case of discrete variables, both exclusive and inclusive class intervals can be used. And in the case of continuous variables, inclusive class intervals are used very often. So we can use intervals in continuous variables such as 56.8 to 66, something like that. We can use fraction values as well.
Yeah.
So next example is, suppose we have data on marks obtained by students in a test and all the marks are in full numbers. Fractional marks are not allowed. Suppose the marks obtained by the students vary from 0 to 100. This is the case of a discrete variable since fractional marks are not allowed. In this case, we are using equal sized class intervals and decide to have 10 class intervals. When the class intervals can take either of the following forms. They are inclusive form of class intervals 0 to 10, 11 to 20, 21 to 30. And there's a difference between 10 to 11, right? When we proceed to each form of class interval,
Yeah.
whereas in exclusive form of class intervals, it takes the value of the previous class interval as well, like the upper limit of the previous class interval. such as 10 is taken in the
Yeah.
second value of 10 to 20. And there's 20 to
Yeah.
30 and so on till 90 to 100. So in the case of exclusive class intervals, we have to decide in advance what is to be done if we get a value equal to the value of a class limit. For example, we could decide that values such as 10, 30, etc. should be put into the class intervals 0 to 10 and 20 to 30 respectively. This can be called the case of lower limit excluded. Or else we could put the values 10, 30, etc. into the class intervals 10 to 20 and 30 to 40 respectively. This can be called the case of upper limit excluded. Example of continuous variable. Suppose we have data on a variable such as height, centimeters, or weight is measured in kilograms. This data is of the continuous type. In such cases, the class intervals may be defined in the following manner, which are 30 kg is equal to 39.999 kg, whereas 40 kg is equal to 49.999 kg, and the next class interval starting from 50. These class intervals are understood in the following manner, whereas 30 kgs or kilograms and above and under 40 kgs. Next is 40 kilograms and above and under 50 kg, and there's 50 kg and above and under 60 kg. There's table 3.4, which shows the frequency distribution of incomes of 550 employees of a company. So in the range or the upper limit or lower limit of 899 and 800, the number of employees are 50, whereas in the 900 to 999 income bracket, there are 100 employees, and from 1000 to 1099, there are 200. From 1100 to 1199, there are 150 employees, and till 1200 to 1299, there are 40 number of employees, and 1300 to 1399, there are 10 employees, which totals up to 550 number of employees. Is that right?
Yeah.
Are we clear with table 3.4? We'll move into adjustment in class interval. A close observation of the inclusive method in table 3.4 would show that though the variable income is a continuous variable, no such continuity is maintained when the classes are made. We find gap or discontinuity between the upper limit of a class and the lower limit of the next class. For example, between the upper limit of the first class, which is 899, and the lower limit of the second class, 900, we find a gap of 1. So how do we ensure the continuity of the variable by classifying data? This is achieved by making an adjustment in the class interval. This adjustment is done in the following way. Find the difference between the lower limit of the second class and the upper limit of the first class. For example, in table 3.4, the lower limit of the second class is 900 and the upper limit of the first class is 899. The difference between them is 1, that is 900 minus 899 is equal to 1, and divide the difference obtained in 1 by 2. That is 1 divided by 2 is equal to 5 or 0.5. Subtract the value obtained in 2 from lower limits of all classes, which is minus 0.5. Add the value obtained in 2, which is to obtain upper limits of all classes. And the upper limit is plus 0.5. Are we clear with this?
Yeah.
Okay. So we need to first subtract the lower limit of the second class and the upper limit of the first class. So we'll get 900 minus 899 is equal to 1, where after we get 1 as the answer, we need to divide it by 2. We get 0.5. And later, we need to subtract the lower class limit minus 0.5. The lower class limit is 900 and minus 0.5. It's 899.5. Is it?
Yeah.
Okay. And after the adjustment that restores continuity of data in the frequency distribution, the table 3.4 is modified into table 3.5. After the adjustments in class limits, the equality 1 that determines the value of class mark would be modified as the following. Adjusted class mark is equal to adjusted upper class limit plus adjusted lower class limit divided by 2. So 799.5 plus 899 plus 799.5 divided by 2 in the table 3.5. So this is just a frequency distribution of incomes of 550 employees company. So how do we
Okay.
get the frequency for each class?
Um,
There's in
don't
the
they
table
usually give it?
3.1. Yeah.
Yeah. Yeah.
And we get frequency of 40 occurs thrice because in the range of 1199.5 to 1299.5, it's 40,
Yeah.
and 0 to 10 can occur only once. 49 occurs 5 times because there's 100, there's 200, 150, and 50.
Yeah.
Okay. The frequency of 40 is 3, 0 is 1, 10 is 1, and 49 is 5, and so on. So how do we get the 49 as 5 times? Shouldn't it be 4? Because it comes in the number of employees of 50, 100, 200, 150. But here it's shown as 5 times. It is 4 times or 5?
Um,
Maybe it occurs in the total number of employees as well, in 550.
that doesn't add 49.
Okay. Probably it only
Maybe
occurs
it's
4 times. Okay.
it adds up to 49 after you add the last two classes.
Yes. So if we add the two classes of 40 and 10 of the number of employees, we get 50, which is also 49 is occurring in the two classes
Yeah.
of the income range of 1199.5 to 1299.5, and the next range is, or the class interval, or the lower limit is 1299.5 and upper limit is 1399.5. If we club these two, we get 49 as the fifth occurrence. And
Yeah.
40 occurs in how many frequencies?
Huh?
40 occurs thrice, once in 40
Uh,
itself.
yeah.
Okay.
4 times, right? It's in
Yeah,
40, it's in 50, it's in
yeah,
100, 200, and 150.
yeah. 100 to 150 does occur. 200 also it does occur,
Yeah.
probably. So here they've given as 3 times. We'll just move forward and let's elaborate on how we got 3 times. But when the data are grouped into classes, as in example 3, the class frequency refers to the number of values in a particular class. The counting of 5 class into or class frequency is done by tally marks against a particular class. Have you studied tally marks in mathematics earlier or in statistics
Yeah.
in class 1 to 10?
Yeah.
Okay. So tallies have 4 markings, and when it reaches 5, we need to cross the tallies.
Yeah.
Okay. A tally is put against a class for each student whose marks are included in that class. For example, if the marks, so it occurs something like this.
Yes.
Okay. So we are clear with this tally. So tally marks are in the class upper limit and lower limit of 10 to 20. There are observations of 8, and we have 8 tally marks here. So this is 5 and this is 3 as given in the table 3.6. So the frequency is
Yeah.
8 and the class mark or the midpoint is 15. So are we clear with this tally marking of 100 students in mathematics?
Yeah.
Okay. So can we move to the next concept?
Yes.
Okay. I'll just draw some diagrams. So this is 5 tally
Yeah.
marks.
Yeah,
And how do we represent 10 here?
you have to put another 5.
Okay. Put another bar, another tally. Okay. Yes, this is 10 now. So the frequency will be 10.
Yeah,
We can just name the class with 0 to 10. There are 10 tally marks, 10 observations, such as
yeah,
we just name this 8, 9. So there are 10 observations here,
yeah,
and there's a frequency of 10. And what else do we need to get here? We need to get the class mark, right?
yeah, 5.
Okay. What is the class mark here? 5. Okay. This is the class mark.
Yes,
This is the frequency.
yeah.
And this is tally marks. And this, what can we call 0 to 10? Is it,
Oh, it is class.
okay. And this is the observations down here.
Yeah,
I'm just drawing it as a rough representation. But in the test or in the notes, it can be represented in a better way, or
okay.
in all in one line, just like how the textbook is depicting it.
Yeah,
So we are clear with this concept of tally marks.
yes,
Okay. So if there are 16 tallies in a class, we put them as 5, 5, and again another 5, and last we put another slash, which
1.
equals 16.
Yeah,
So
yes,
this is in quite a reasonable concept of tally marks. This will surely be given in the notes or in the tests or the assessments as well. And this
okay.
loss of information is the next concept. The classification of data as a frequency distribution has an inherent shortcoming. While it summarizes the raw data, making it concise and comprehensible, it does not show the details that are found in raw data. There is a loss of information in classifying raw data, though much is gained by summarizing it as a classified data. Once the data are grouped into classes, an individual observation has no significance in further statistical calculations. In example 4, the class 20 to 30 contains 6 observations: 25, 25, 20, 22, and 25, and 28. So when these data are grouped as a class 20 to 30 in the frequency distribution, the latter provides only the number of records in that class, that is, frequency is equal to 6, but not their actual values. All values in this class are assumed to be equal in the mid value of the class interval or class mark. Further, statistical calculations are based only on the values of class mark and not on the values of the observations in that class. This is true for other classes as well. Thus, the use of class mark instead of the actual values of the observations in statistical methods involves considerable loss of information. However, being able to make more sense of the raw data as shown more than makes this up. So we'll just read through with the frequency distribution with unequal classes as well. We are familiar with frequency distribution of equal class interval. We also know how they are constructed out of raw data, but in some cases, frequency distributions with unequal class intervals are more appropriate. If you observe the frequency distribution of example 4, as in table 3.6, you will notice that most of the observations are concentrated in classes 40 to 50, 50 to 60, and 60 to 70. Their respective frequencies are 21, 23, and 19. It means that out of 100 students, 63 students are concentrated in these classes. Thus, 63% are in the middle range of 40 to 70. The remaining for 37% of data are in classes 0 to 10, 10 to 20, 20 to 30, 30 to 40, 70 to 80, 80 to 90, and 90 to 100. These classes are sparsely populated. Can this be called equal class intervals?
Yeah,
Whereas 40 to 70 can be called unequal class interval?
42. No, that is still equal, but
Okay,
the class interval changes.
okay. These classes are sparsely populated with observations. Further, you will also notice that observations in these classes deviate more from their respective class marks than in comparison to those in other classes. If classes are to be formed in such a way that classes or class marks coincide as far as possible to a value around which the observations, so this is the frequency distribution of unequal classes represented in table 3.7.
Yeah,
So there's an unequal class which starts from 40 to 45, because still 40 is 0 in the range of 10, right? The lower
yeah,
limit is 10 and upper limit is 20 in 10 to 20, whereas 20 to 30 also there's equal class width of 10. 30 to 40 also has equal class width of 10. But whereas
yeah.
in 40 to 45 and 45 to 50, there's unequal class intervals till 60
Okay.
to 65, whereas till 70, there's from 40 to 70, there's unequal class intervals here, as we discussed.
Yeah,
And the class midpoint is the value between 65 to 70, 65, 67.5. So there's just a class width of 5 from 65 to 70. That's right.
si- yeah,
Okay. And also the classes tend to concentrate than unequal class interval is more appropriate. Table 3.7 shows the same frequency distribution of 3.6 in terms of unequal classes. Each of the classes 40 to 50, 50 to 60, 60 to 70 are split into two classes. 40 to 50 is divided into 40 to 45 and 45 to 50. The class 50 to 60 is divided into 50 to 55 and 55 to 60. And class 60 to 70 is divided into 60 to 65 and 65 to 70. So we'll take a quick 1 minute break and we'll be back.
okay.
So there's also next concept called frequency array. Before that, there's an activity. If we compare figure 3.2 with figure 3.1, what do we observe? Do you find any difference between them? Yes. Can we get back into the class?
So,
Yeah.
yeah, 3.2 and 3.1 are not in my book. Is it the wheat and the population one?
It is, this is, yes, we'll just go figure 3.2 and 3.1, right?
Yeah, it says it's not
Yeah,
written
it's
as
wheat and
3.2
the
and 3.2.
population.
Oh no, it's
It
marks
is
and
diagrammatic
maths
representation
and
of frequency distribution of data. This diagram on page 29.
okay.
And there's another figure which is given in as 3.2, figure 3.2. Is it given? The next page here. So have we found out 3.2? Not yet.
I haven't found it yet.
There are a lot of tables and activities as well. You just need to find out 3.2 because we've got the frequency distribution for 3.1.
Yeah.
This is 3.1. Yeah. Probably we have to scroll down.
Okay.
Okay.
Yeah, I
It's
found
given
it.
in
It's
this
on
page.
page
Yeah.
35.
It's on a
Yeah,
frequency curve. So there's a representation diagrammatically, and from
yeah,
40 to 60. So the x-axis plots the frequency here,
yeah,
and the y-axis can it plot the class intervals
yeah,
or the upper limit and lower limit from 0 to 5 to 5 to 10 and 10 to 15,
yeah,
and also from 15 to 20. Can it be called the class intervals or the lower limit and upper limit?
yeah,
Okay, and frequency is plotted on the x-axis. Okay. So
yeah.
do we find any difference between figure 3.2 and 3.1? Just go back to 3.1 again. So are there
Uh,
any differences here?
Not really.
Maybe there's not really, right?
Yeah,
Only the frequency might change, so the number of observations. But diagrammatically,
yeah,
it's similar,
yeah.
and the class interval also is from uh,
5 to, I mean,
uh
0 to 5, 5 to
yeah,
10.
or is it from 0 to 20?
Uh,
Because in
oh,
table
yeah,
3
yeah,
point,
class interval. Yeah, yeah. Sorry, I was looking
yeah,
at the frequency.
so it's on the y-axis, right?
Yeah,
And we just need to go down. There's the next concept of bivariate frequency. Before that, we'll study frequency array. So we have discussed the classification of data for a continuous variable using the example of percentage marks of 100 students in mathematics. For a discrete variable, the classification of its data is known as a frequency array. Since a discrete variable takes values and not intermediate fraction values between two integral values, we have frequencies that correspond to each of its integral values. The example in table 3.8 illustrates a frequency array. There's the size of the household is 1 and number of households of 5, whereas in the size of household 2, there's 15 number of households. So what is a
yeah,
frequency array? It is just a classification of data for a discrete variable because it does
yeah,
not take any fractional values
yeah,
between two integral values. So therefore, we have frequencies that correspond to each of its integral values. So we also have the variable size of the household is a discrete variable that only takes integral values as shown in the table. So there are only integral values, there are no fraction values here.
yeah.
So do we require another session today to complete the chapter 3? Can
Today,
we schedule it?
okay.
What
We
time?
just need to finish the bivariate, right?
Yes. What time can we have it? Quick, because we have just 30 seconds left.
Can we do it now only after this?
Yes, we
If
can
it's possible.
schedule another session at 11:55.
Yeah,
So
okay,
from 11:55 to 12:40.
okay,
Thanks a lot for joining in the fifth session. We'll get back and we'll see you in the sixth session.
okay. Thank you, sir.
Have a great day.
Yes.